This is lecture 3. Hello everyone. In this video, lecture 3, we are going to discuss about counter programming. C by DT bit in the mod register helps us to identify that the register is taken as counter or timer. So we use the C by T bit. Okay. So as usual, the counter will increment TH and TL registers, and counter mode will be identified. Uh, we using a T mod will set the mode, and we use TH and TL register for counting purpose, as we have done for the timers. So let's proceed. Now let's see the actual procedure in detail. C by T bit in T mod register decides the what type of counter it is, counter or timer it is. If you have 0 bit here, timer gets pulse from crystal. That is, it acts as time. If you have 1 here, then it is counter. Counter gets input from the outside device. Okay, so it becomes counter now. Similarly, here T1, the timer gets output count and is fed to pin 14 and pin 15, that is T0, T1 pins of microcontroller. So these two pins belongs to port 3 here. Now for timer 0, C by T equal to 1, port 3's fourth pin provides the clock pulse, and the counter clock ups for each clock pulses coming from that pin. If we have timer 1, C by T equal to 1, each clock pulse coming from port 3's point 5 makes a counter up. So in this way it starts counting. So this is the port 3.5 pin is for timer 1 and port 3.4 is for timer 0. So these are the details here. Now let's see the template. Port 3 pins used for timer 0 and 1 here. We have timer 0 pins and timer 1 pin, and T0 and T1 is pin number 14 and pin number 15. That is actually port 3's fourth bit, port 3's fifth bit. T0 for timer 1, timer 0, T1 for timer 1. So both of them taken as external inputs here. Now let's see the program. Initially, the counter mode is set, sending this value into Tmod. This is the program which explains clock pulses is fed to T1, and we are writing a program for counter 1 in mode 2, which starts counting and displays the same state in TL1. So we are sending this value so that it enters into Tmod, selects counter 1 and mode 2, C by T equal to 1. These are the bit positions of this format, that is 1 1 0 0. If I fill all this, I'll be getting the code. So 0 1 1 0 0 0 0, like this. That value is obtained here, so that it is entered into Tmod register. TH1 is taken as 0, clearing the TH, and then making T1 bit high. We are setting that with 3.5, timer 1 here, and then again we are starting the timer here. TR1 is taken, it is set here. So move A comma TL1. The copy of TL1 is moved into A here. Okay, and then the next one is A value is moved into port 2 for the display, and we are frequently checking the flag register continuously. When flag register is changed, it comes out of the loop, otherwise it will be executing the same, and then after that it clears the TR register, timer run register, and then flag register is cleared. Again the loop is going to again step here. So in this way it enters into the loop. So this is the program for counter. If you see the hardware, P2 is connected to LEDs, 8 LEDs, and T1 is the input to the pulse. So the pulse is given to P3.5. Accordingly, P2 connected to LED, so that we can see on the display what is the actual count. So there is the diagram which indicates timer 0 with external input in mode 2, and C by T is 1. External input comes on port 3.4 bit, and then TR is given here, and then this goes to auto reload mode. So TL is moved into A here, and from that A moves to port for display. So like this it goes on. Once the value is changing, a copy of this enters into TL again. TH holds the value. We are not disturbing the TH value. Only TL is used for decrementing or incrementing counting purpose. And then once overflow occurs, TF flag will affect. So in this way the operation is done. And this is for timer 1. Situation repeats same, but it is for timer 1. Timer 1 registers are taken. And here we have the same. Let's see the bits here for timer 0. What is the bit? The format given is for TCON, timer control register. Timer control register. So the bits identified here are related to control mode registers. So this is the flag register. Timer 1's these bits, wherever 1 is, it relates to timer 1. Wherever 0 is, it relates to timer 0. TF means flag register, TR means the timer run register which starts counting, and then here IE means external interrupt 1. External interrupt 1. If it is 1, external interrupt 1 is occurred. If it is 0, external interrupt 1 processed. Whereas IT1 is external interrupt 1 trigger type selection is done here using this. So if it is 1, occurs on falling edge at INT1 input. If it is 0, it occurs on low level edge at int input. So this is interrupt, external interrupt trigger type selection. Similarly, we have for timer 0 also the interrupt, external interrupt, as well as external interrupt type selections, both for timer 0. So this is about TCON. The bit numbers are, the instructions are mentioned here with this is bit addressable, so only we are using TCON dot pin number. TCON dot pin number. Set to clear is set to clear. Set in the sense it will be 1, clear in the sense it will be 0. So whatever I have explained, it is mentioned in those points. And then this is the format for TCON. Gate 1 in T-mode register, we already know what is the purpose of gate here. Gate 0 indicates timer is started with instructions set TR0 or set bit TR1. Whereas if it is 1, start and stop bits of the timer are done externally. If we have gate as 1, start and stop bits are monitored or controlled with external, which is connected to port 3, second pin and third pin, and allows us to start and stop the timer externally at any time via simple switch. So the hardware can be extended with these pins so that we can start and stop externally. That's the block diagram which shows the detailed operation of timer counters here. So gate bit and int bit, both of them should be given properly, and then TR0 starts the counting purpose, and then TON, we have these bits here. Clock frequency is divided and then given here. Okay, this is internal given pulse when it is the timer. If you have as a counter, we'll take the input from external device. External device will be there and it will be connected here. And then the operation continues. In this way, the timer and counter works. And this is for timer 1. In the previous case, this is for timer 0. Thank you.